Okay, so for my code overview, I'm going to be talking about one of the modules that I designed, which is called the military hour display. And what this module does is it actually computes and calculates the 24-hour time display and increments it by a second using the second clock, which I also made. And so it takes in inputs, which are organized here. We have input hour by tenths, input hour by ones, input minutes by 10, and input minutes by 1. And so these inputs are what are fed into it to know when to set the alarm and when to set the actual time. These outputs here are then written onto the 7 segment, and that's how you actually get the time display. And so we have the alarm set input, the clock set input, and then a button that will reset the alarm, and a light that will turn on when the alarm is being set, because I didn't actually get to add the audio portion. So down here we talk about the temporary registers, which are holding the temporary values for hours, minutes, and seconds, and they are a register holding 6 bits, so that way they can go up to 64, which then would hold the max value for each of those. Then we also have the clock times, and we have the alarm times, C representing clock, A representing alarm, H representing hours, M minutes, S seconds, and then again, tens and ones position. Next, I have a function that computes mod 10. This is just here because I later on need the modulus operator, mod 10 specifically. Moving down, you can see that if the reset is said, then we're going to just put the temporary values. We're just going to reset to the temporary values. The alarm set then sets it sets a parameter into the alarm holding value, and then when this value gets crossed later on, you'll see that then sets off the alarm trigger. Clock set does the exact same thing as reset. It's just clock set is a way to set it with a switch rather than having to push a button. Here we have the iterator. This determines when temp seconds hit 60, it adds a minute. When temp minutes hit 60, it adds an hour. And when temp hours goes over 24, it then resets to 0. And this is because this is the 24-hour military time display. Down here, we talk about the basic computation that happens to calculate the time. And then this is the time that gets output. So this is how you calculate the time that goes out. And you do that by taking the temp and then computing first the mod 10 of it using if statements, and then that gets used later on to calculate the rest of the mod 10, as you can see. And then we assign these to the output, and we output this. And then also here's the alarm. So if the reset is ever pushed or if alarm off is pushed, then it resets the alarm to be 0 again. And then if the alarm ever equals what the current clock is, then the alarm gets set to signal to 1. Otherwise, the alarm just stays at what the alarm is. And we're going to assign the temporary alarm to the actual alarm, which is an output, as you can see defined up here. Okay, that should have been 2 minutes, I think.
These three here, this controls the tens for the hours. So this is 2, 1, 0. These control the next portion of hours. So this will control like the tens. So this will be 8, 4, 2, 0, and or 1. That's just to include the ones position. And then again, it's gonna have the tens and then the ones for minutes, because I wasn't gonna include seconds because
Hellfire.
yeah, if you really need to be there in a second, it doesn't work, whatever. And
okay,
this is the set
so it's all in
time.
binary to increase the value.
And then this is the set time. So you flick this, it pauses it, resets it, puts it where you're at. And so let's say I want to increment this to be 30. That's 30, 31, because that's the current time. What was on 31. And then I turn it back off, and now the time is set. You can turn it back on the timer. And let's say I set the alarm to be something astronomical. So right now this one's at 30 hours, which is impossible. And then I reset the alarm. It's not gonna go off. Then I can also reset the clock, which resets the current configuration. Or I can change the current config to match what's going to be in a second. And then when it hits that, I can just refresh it. So when this hits, when this hits 9:32, I can just press refresh, and it'll put it back at the proper time.
Nice. Wonderful.
So for successes and failures on the project, I would have to say some of the successes were successfully finishing most of the lab. I would have been able to finish the whole lab if I had my lab partner's contribution and help throughout the lab. but the part of the lab that he had said that he would help finish and the modules that he said he would help create were never created. So today at 11:30, currently 10:03 p.m., I finished the entire lab, not the entire lab, most of the lab by myself. I think the success is that I learned and fully understand how clocks, rotations, um, synchronous patterns work in Verilog, and I think one of the biggest failures that I had today was not fully understanding the 7 segment and how to swap anodes properly.